Hi students, welcome to our algebra lesson today. And we're going to start by going over what we're going to do today and some things that are coming up in algebra. We'll start with our do now. We will respond in our class notebook to a prompt about resiliency, that ability to bounce back from adversity. Our objective today will be to review systems of equations. Our essential question will involve solving systems by graphing, by substitution, and by elimination. Remember, for participation credit, we're going to do our do now. We're going to complete 12 problems today, showing every step toward finding the solution. We're going to turn in photos of our work and complete the exit ticket. For homework, you have a review, 511 review, and we know these all important notes. You should review them every day. Remember, we have after-school help if you need it. Now, something new, we have a Unit 5 test coming up, and that will be on Tuesday, March 1st. We'll come back to that exit ticket. So let's talk about resiliency. Resiliency is the ability to bounce back, to be resilient. It could be illness, depression, adversity. And this year you've learned a lot of problem-solving skills. I want you to think about how those problem-solving skills that you've learned can help you overcome obstacles and resolve conflicts. You've learned mindfulness, you've learned resolution strategies, you've learned how to get along well with others. Many of you have been champs at distance learning. That, to me, is an adversity. So let's hear your thoughts right here. So let's get into the lesson. We're going to do 3 topics today. We're going to solve systems by graphing. We're going to solve them by substitution and by elimination. So the first thing we need to do if we're going to hand graph anything is we need to have it in slope-intercept form. So I'm not going to spend a lot of time telling you how to put them in slope-intercept form. Basically, you're solving for y because you want y equals mx plus b format. You need to go back to Unit 2 if you're forgetting how to do that, but I think most of you know how to do that. But this first equation in slope-intercept form would be y equals negative x plus 2. And the second equation would be y equals x minus 4, because we have to divide by negative 1 because of that negative y. So for the first equation, we have a y-intercept of 2 and a slope of negative 1. So let's try to use our arrows. Okay, roughly speaking, that's the first equation. Let's see. The second equation, we have a y-intercept of negative 4 and a slope of 1. We can see already where our solution is. Okay, so the solution to this equation is right here at the point 3, 1. And that's the solution, 3, negative 1, excuse me. That's the solution to this equation, 3, negative 1. All right, second problem. So we've got 3x minus 5y equals 15. So in slope-intercept form, that would be y equals 3/5 x minus 3. And the second equation is already in slope-intercept form. So let's start with our first equation. We have a y-intercept of negative 3. And we have a slope of 3 over 5. It's a positive slope. So 1, 2, 3 over 5. And let's see if we can get another point in here. We go down 3 and over 5. Let's try to graph this. I wonder if we can make the line a little bit thicker. And let's graph y equals 2x plus 4. So we've got a y-intercept of 4. 1, 2, 3, 4. And we have a slope of 2. And we can see that the solution to this system of equations is right here at -5, -6. Okay, third problem. Again, we need to be in slope-intercept form first. So the first equation in slope-intercept form will be y equals 1/4 x minus 7. And the second equation in slope-intercept form, y equals -1/2 x minus 1. So let's graph the first equation. We're looking for a y-intercept of -7. 1, 2, 3, 4, 5, 6, 7. And a slope of 1/4. So 1, 1, 2, 3, 4, 1, 1, 2, 3, 4. And for the second equation, we have a y-intercept of -1 and a negative slope of 1/2. So 1, 2, 2, 1, 2, 1, 2. And we can see that the solution to this particular equation is right here, 8, -5. So 8 on the x-axis, -5 on the y-axis. And finally, number 4, the first equation in slope-intercept form will be y equals 4/3 x plus 5. I'm actually going to do that. It doesn't seem right. So let's work on this. 3y equals 4x minus 6. Divide everything by 3. Y equals 4/3 x minus 2. Okay, and the second equation, 8x minus 6y equals -30. Negative, move 8x over first. Okay, I see what's going on. Divide by -6. And y equals negative divided by negative is positive. Divide by 2 there, so that would be 4/3 x plus 5. So I'm hoping that you already see what's going to happen here. We have a slope of 4/3 in both of these equations, okay? What kinds of lines will these be? I hope you remember. So let's graph the first one. We'll graph this one first. We have a y-intercept of -2 and a slope of 4/3. And the second equation has a y-intercept of +5 and again a slope of 4/3. 1, 2, 3, 4. 1, 2, 3. We'll graph this. And we see that those two lines having the same slope are parallel. So the solution is no solution. Oops. Okay, topic 2, solving systems of equations by substitution. So we have y equals 2x plus 3 is our first equation. Y equals -x minus 9. Well, we already have them both solved for y. If they're both solved for y, we just set them equal to each other. And let's add x to both sides. And let's subtract 3 from each side. And let's divide by 3. And x equals -4. Now we're going to substitute -4 let's substitute it into the second equation. I'll change our color. So y equals, now look at this, I want you to see this. Okay, I substituted very carefully. I've got a -4 within the parentheses, and I also have this negative sign outside. So subtracting a negative is the same as adding. So in this case, y equals -5. So my solution is -4, -5. Okay, number 6. We have 2x plus 3y equals 4, and the second equation is already solved for y. So I'll just use that for the substitution. So I'll have 2x plus 3, and instead of y, I've got this quantity, 5x minus 27 equals 4. Now, first thing I need to do is distribute. 2x plus 15x minus 81 equals 4. Now we combine like terms, so that would be 17x minus 81 equals 4. Now I add 81 to both sides. 17x equals 85, and I divide both sides by 17. And x equals 5. Now I'm going to take that 5 and insert it into this equation for x. So y equals 5 times 5 minus 27. So 5 times 5 is 25 minus 27. And so y equals -2. And then our final solution then is 5, -2. Okay, let's do a couple more of these substitution ones. We have x plus 4y equals 19 and x minus 2y equals 1. I'm going to solve this second equation for x because it's pretty easy to do. I'm just going to move 2y over and this negative will become a positive. So I'm going to have x equals 2y plus 1. Put that in parentheses and use it to substitute for x in the first equation. So 2y plus 1 plus 4y equals 19. So 2y plus 4y is 6y plus 1 equals 19. We subtract 1 from each side. 6y equals 18. We divide by 6. And y equals 3. Now I'll take that 3 and I'll substitute it. I'll choose the second equation. It doesn't matter. So x minus 2 times 3 equals 1. X minus 6 equals 1. Add 6 to both sides. And x equals 7. So our final answer is the ordered pair of 7, 3. And our last substitution problem, I'm going to take, 6x minus y equals -21, 5x plus 3y equals 17. I think the smartest thing to do is isolate this y. And when I do that, I have y equals 6x plus 21, and this became positive when we divided by -1 to isolate y. So now that I have y isolated, I'm going to insert it for y in the second equation. 5x plus 3, and I've got that quantity of 6x plus 21 equals 17. Now I need to distribute. So 5x plus 6 times 3 is 18x plus 21 times 3 is 63 equals 17. Now I'll combine like terms. 18 and 5 are 23, so I've got 23x plus 63 equals 17. I'll subtract 63 from each side, and 23x equals -46. And when I divide both sides by 23, x equals -2. Now I'll take that -2 and I will insert it into the second equation for x. So 6 times -2 minus y equals -21. Actually, you know what I could have done? I could have inserted it right here too. That might have been a little easier. But let's see how we do. So we've got -12 minus y equals -21. Add 12 to both sides. Negative y equals 9. And that's going to be a -9. And then we divide both sides by -1, so we can isolate y, and y equals a +9. So our ordered pair is -2, 9. And then finally, let's do 4 elimination problems. So these are the ones that take a little bit longer. So I've got x minus 3y equals negative 13, 3x plus 7y equals 25. If I multiply this first equation times 3, I will have 3x in both equations. So let's do that. So that will give me 3x minus 9y equals negative 39. And then I've got my second equation, 3x plus 7y equals 25. And then I'm going to subtract the second equation from the first. Be mindful of that negative sign there, of that subtraction. So the 3x's are eliminated. That's why it's called elimination. So negative 9y minus 7y, remember we're subtracting over here, is negative 16y. And negative 39 minus 25 is a negative 64. Now we're going to divide by negative 16, which means y equals a positive 4. Negative divided by negative is a positive. Easy part now. I'm just going to insert y equals 4. I'll choose the first equation and put it right here. So I will have x minus 3 times 4 equals negative 13. X minus 12 equals negative 13. Add 12 to both sides. And x equals negative 1. And my final answer, negative 1, 4. Okay, let's see what we have here. We have 2x plus 8y equals 6, and 5x plus 20y equals 15. I think I'd like to eliminate the x's, and if I multiply the first equation by 5 and the second equation by 2, then I'll have 10x, and I can work with that. So let's multiply the first equation by 5, which will give us 10x plus 40y equals 30. And we'll multiply the second equation by 2. That will give us 10x plus 40y equals 15 times 2 is 30. I hope you can see what's already happening. If I subtract the second equation from the first, I end up with 0 equals 0. What this means is that both of these equations are the same line or graph, okay? That means there is an infinite number of solutions. And let's look at number 11. So I think what I'll do, I have 7x minus y equals 19, and 2x minus 3y equals 19. So I'm going to multiply the first equation by 3. And can you see what I'm aiming to do? I'm going to eliminate y. So 7 times 3 is 21x. Negative 1 times 3 is negative 3y. And 19 times 3 is 57. And then I've got my 2x minus 3y equals 19. Now, be careful here. Let me change the color so you can see it. I am going to subtract the second equation. When I subtract a negative, that's like making it positive, so the 3y's go away. 21 minus 2 is 19. So I have 19x equals 57 minus 19 is 38. And if I divide both sides by 19, x equals 2. So I'm going to take that 2 and I'm going to insert it right here for x in the second equation. So 2 times 2 minus 3y equals 19. And we'll solve for y. 4 minus 3y equals 19. I think I will subtract 4 from each side, which eliminates the 4 there. I'll have negative 3y equals 15. And then I'll divide both sides by negative 3 for y equals negative 5. And my ordered pair, that is the solution to this system, is 2, negative 5. And finally, number 12. I've got 4x minus y equals negative 4, and 5x equals 2y plus 1. Be careful here. These are not in exactly the same format. So first thing I want to do is I want to move y to the other side of the equation. I have to move y over here, which will make y positive. So that will be 4x equals y minus 4. And then my second equation, 5x equals 2y plus 1. Do you see what I had to do there? I had to align the x and y values with their respective side on the equal sign. There are a number of ways you could have done that to align them up. That just to me seemed much easier to just move y to the other side, to the right side of the equal sign. Now, I think what I'd like to do is eliminate the y terms. So I'm going to multiply this first equation by 2. And when I do that, I will have 8x equals 2y minus 8. And then I'm going to write my second equation down. So this is this equation. Now I'm just going to copy this equation right here. 5x equals 2y plus 1. Now now that I've got 2y, I'm going to subtract the second equation from the first. That eliminates my y values. And then 8 minus 5, that's 3x, equals 8 minus 1 minus negative 8 minus 1 is negative 9. And I'll divide both sides by 3, and x equals negative 3. I'm going to take that negative 3 and I'm going to insert it right here for x in the first equation. So I've got 4 times negative 3 minus y equals negative 4. So that's negative 12 minus y equals negative 4. I'll add 12 to both sides of the equation. Now remember, when you have negative y, it's not isolated. We're going to have to divide by negative 1 at the end. So negative 4 plus 12 is negative 8. And then I divide by negative 1. And y equals 8. Equals, I'm sorry, this is positive. This is negative 4 plus 12, positive 8, divide by negative 1. Yeah, y equals negative 8. Okay, so we've got negative 3, negative 8 for our final answer. Now you can graph all of these on Desmos, and you would easily see what the correct answers were. And you would see that overlapping number 10 here, where you have both lines are the same. So there's an infinite number of solutions for that one. These take a bit of practice. You really got to do a couple of these every day. You have an opportunity tonight to do 6 of them, okay? I recommend that you do that and come to school tomorrow with your questions. Let's go back to that exit ticket. So the Unit 5 test will be on Tuesday, March 1st. In order to prepare, what will you do? And I want you to write down here all the things you're going to do to prepare for your unit test so you can be successful in algebra and move on to geometry. So keep practicing and keep working hard. As you do, you will certainly be great in algebra.